Welcome back to the Deep Dive, where we plunge headfirst into the fascinating, the complex, and sometimes, well, the truly mind-bending.
That's a good way to put it.
Today, our gaze is fixed on a place that has captivated humanity for millennia. A place just steeped in wonder and these enduring questions. The Giza pyramids and that enigmatic Great Sphinx.
Absolutely iconic.
Just seeing images of these ancient wonders, they immediately spark an almost primal curiosity, don't they? How were they built? What was their true purpose?
Right, a big questions.
What kind of profound knowledge did their builders possess that allowed them to create such colossal and precise monuments? These aren't just massive stones standing testament to a forgotten past. They are structures shrouded in layers of mystery, inviting endless interpretation and, frankly, a lot of incredibly imaginative theories.
And that's putting it mildly sometimes.
And that's exactly where we're headed today. We're about to embark on a deep dive into one of the most intriguing and, let's be honest, hotly debated theories surrounding these incredible structures. The Orion Correlation Theory.
Ah, yes, the OCT.
This isn't just a hypothesis. It's a grand vision that attempts to connect the very stones of Giza to the stars above in a way that challenges our conventional understanding of history itself.
That's right. For this deep dive, we've taken a stack of sources, primarily a comprehensive and, well-vetted Wikipedia entry, which itself pulls together information from numerous academic and popular sources to really extract the core ideas of this specific theory.
Okay.
Our mission here isn't to take sides or to endorse or to prove anything. Instead, our focus is squarely on understanding what the Orion Correlation Theory posits in detail, who developed it and popularized it, and critically how it has been received by mainstream science and the broader public. It's about tracing the journey of a big idea.
Exactly. As always, our goal, our mission for you is to leave this conversation exceptionally well informed. It's about more than just knowing what the theory is. It's about understanding the compelling arguments that proponents make. And equally, the rigorous counter-arguments brought forward by astronomers, archaeologists, and geologists. We'll be sifting through the layers of information, appreciating the surprising facts that emerge from both sides, and weighing the evidence.
Trying to see the full picture.
You'll walk away from this deep dive with a much clearer understanding of how theories like this are constructed, the specific claims they make, how they gain such significant traction in the public imagination, and importantly, how they stand up to rigorous scrutiny from the scientific community. So buckle up, because what we're about to explore here gets truly fascinating.
It certainly does.
So let's jump right into the very heart of the matter. The foundational concept of the Orion Correlation Theory suggests something truly extraordinary.
It really does.
That the arrangement of the three largest pyramids at Giza, that's the Great Pyramid of Khufu, the Pyramid of Khafre, and the Pyramid of Menkaure, isn't just some random placement on the desert sands, or even a purely functional architectural choice.
No, not at all, according to this theory.
It proposes something much more deliberate, much more cosmic, a direct reflection of the heavens.
Indeed. The core proposition of the Orion Correlation Theory, often referred to as OCT, is that these three prominent pyramids at Giza are directly correlated in their precise location and their overall layout with the three bright stars that form what we know as Orion's belt.
Okay, Orion's belt, the famous three stars.
That's them. Those stars are Alnitak, Alnilam, and Mintaka. If you visualize them in the night sky, the theory specifically proposes that the brightest star in the belt, Alnitak, corresponds to the largest pyramid, the Great Pyramid of Giza.
Makes sense. Brightest star, biggest pyramid.
Right. The central star, Alnilam, is mapped to the Pyramid of Khafre, and Mintaka, the third star, is aligned with the Pyramid of Menkaure.
The smallest of the three main pyramids.
Exactly. What's particularly highlighted by Robert Bauval, the amateur Egyptologist and author who first published this idea, is a very specific observation he made back in 1989.
Okay, what did he notice?
He noticed that Mintaka, the dimmest and most westerly star in Orion's belt, is not perfectly aligned with the other two. It has a slight, subtle offset or deviation in its position from a perfectly straight line.
Ah, right. I think I can picture that in the sky.
Yeah. Bauval observed that this subtle deviation in the star's celestial position appears to precisely mirror the slight deviation or offset of the Menkaure pyramid from the general alignment of the other two larger pyramids on the Giza plateau.
So the slight kink in the stars matches a slight kink on the ground.
Precisely. This specific, almost subtle mirroring of a minor irregularity is seen as a key piece of the puzzle for proponents of the theory, suggesting an intentional design rather than mere coincidence.
I can see why that would be compelling. It feels too specific to be random.
That's the argument. Furthermore, and this adds a profound layer of ancient Egyptian cultural and religious context, the stars of the constellation Orion were deeply associated with Osiris in Egyptian cosmology.
Osiris, the god of the underworld and rebirth.
The very same. For the ancient Egyptians, Osiris was an incredible central deity, the god of the afterlife, the underworld, and rebirth. He represented the cycle of death and resurrection, essential for the pharaoh's journey to the stars after his earthly reign.
Ah, okay, so there's a direct link to their beliefs about death and the afterlife?
Absolutely. So if this correlation between the Giza pyramids and Orion's belt were true, it would imbue the entire pyramid complex with an immensely profound spiritual and symbolic significance, directly linking the earthly monuments' tombs meant to ensure eternal life to the divine realm and to the very concept of eternal life and resurrection in their cosmology.
Wow.
It elevates the Giza Plateau from just a necropolis to a sacred, astronomically aligned landscape.
That connection to Osiris immediately makes the theory even more compelling, adding that spiritual and cosmological depth. It transforms the site from just colossal tombs into a sacred landscape designed to mirror the heavens. But does the theory stop there, with just the three main pyramids mirroring Orion's belt? Or does it expand beyond that core alignment to encompass more of Giza? What's the grandest vision proposed?
Oh, it absolutely expands. The vision isn't limited to just the three main pyramids. Depending on which version of the theory you're exploring, the proposed celestial map can become much more expansive, even breathtaking in its scope.
Really? Like what?
Some proponents, including Bauval himself, extend the correlation to include additional smaller pyramids or mastabas within the Giza complex to complete a broader picture of the entire Orion constellation, not just its prominent belt.
So mapping even more stars.
That's the idea. This suggests an even more elaborate and detailed celestial blueprint being meticulously laid out on the ground, indicating a profound astronomical knowledge among the builders.
Okay, that's already pretty grand.
But the theory takes an even grander leap, one that truly defines the cosmic blueprint concept. One of the most sweeping extensions of the Orion Correlation Theory proposes that the Nile River itself corresponds to the Milky Way galaxy.
And the Nile is the Milky Way.
Yeah,
Seriously.
seriously. The idea is that just as the Milky Way serves as a celestial river of stars, the Nile, the lifeblood of ancient Egypt, was intended to be its terrestrial counterpart.
Wow, okay.
If you connect these dots, the pyramids as Orion and the Nile as the galactic river, you begin to see a proposed massive terrestrial celestial map. This vision paints a picture of the Giza complex as a complete giant astrolabe, or a direct, precise reflection of the heavens.
A map on the ground mirroring the sky.
Meticulously designed and placed by its builders as a monument to their advanced understanding of the cosmos and their place within it. It's a very romantic, almost poetic idea of ancient cosmological architecture.
It's quite an astonishing vision, isn't it? This grand design of the entire Giza complex mirroring the cosmos, a frozen astrolabe of staggering scale. So how did this theory, which sounds like something straight out of a speculative history novel, actually emerge from academic discussions and become so widely known? What was its journey into the public consciousness?
Well, the theory's journey from a niche observation to widespread public awareness began quite precisely. As I mentioned, Robert Bauval first formally published his idea in 1989.
Okay, where did it appear first?
It appeared in an academic journal, Discussions in Egyptology, specifically in Volume 13. This was its initial academic debut, a technical paper laying out the foundational observation about the pyramid star alignment, intended for scholarly review.
So it started in a fairly specialized place.
Yes, but its rapid popularization truly took off in the mid-1990s, transcending those academic circles. In 1994, Bauval co-authored the highly influential book, The Orion Mystery, with Adrian Gilbert.
Right, I've heard of that one. That was huge, wasn't it?
Massive success. It translated the technical arguments into an accessible, compelling narrative that resonated deeply with a much wider, non-specialist audience. The same year, in February 1994, the theory also gained significant visibility through a BBC documentary titled The Great Pyramid: Gateway to the Stars.
Ah, the BBC effect.
Exactly. This documentary showcased the theory on a major public platform, exposing it to millions of viewers globally and, legitimizing it in the eyes of many.
So book and documentary, big pushes.
Huge pushes. From there, the theory's reach continued to grow exponentially. It crossed over into various New Age books, alternative historical narratives, and eventually the nascent internet, where such ideas found fertile ground among those seeking explanations beyond conventional academia.
Right. The early internet loved this stuff.
Yeah. Absolutely. This signaled its acceptance and integration into broader circles interested in ancient mysteries, spirituality, and unconventional explanations for historical phenomena. Bauval's collaborations also expanded beyond Egyptology. He went on to work with other authors, often associated with what scholars term pseudoscientific claims,
Okay.
most notably Adrian Gilbert and Graham Hancock. This collaboration, particularly with Graham Hancock, was significant because it helped expand the theoretical framework beyond pure Egyptology, connecting it to much larger ideas about lost civilizations and ancient global knowledge, which really sets the stage for our next section.
Graham Hancock, yes. That connection definitely broadened its appeal and its implications.
The synergy between their ideas amplified the reach and influence of the Orion Correlation Theory significantly.
Okay, let's really unpack this, because one of the most provocative and certainly radical aspects of the Orion Correlation Theory isn't just about the alignment itself, but about the age it implies for the Giza complex.
Yes, this is where it gets really controversial.
It suggests a construction date that is far, far older indeed, millennia older than what mainstream archaeology has ever accepted, and this has profound implications for our understanding of human history.
That's right. The core proposition regarding the age of Giza, as put forth by Bauval and especially expanded upon by Graham Hancock, is truly radical. The Orion Correlation Theory claims that the alignment of the Giza pyramids with Orion's belt is meant to reflect how these stars appeared in the sky, specifically around 10,000 BC.
10,000 BC, that's way before the pharaohs we associate with the pyramids.
Way before. This is a date that pushes the timeline back by roughly 7,500 years compared to the conventional archaeological dating. It's an astronomical timestamp, frozen in stone, from an epoch we rarely consider as having such advanced engineering.
So how do they arrive at that specific date, 10,000 BC?
Well, this specific ancient dating ties directly into a critical astronomical concept known as the precession of the equinoxes.
The Earth's wobble.
Exactly. For those unfamiliar, the Earth's axis isn't static. It undergoes a slow, continuous wobble, much like a barely perceptible spin of a dying top. This wobble causes the apparent position of the stars in the night sky to shift very gradually over vast periods of time, roughly 1 degree every 72 years, completing a full cycle in about 26,000 years.
Okay, so the view changes over millennia.
Dramatically. This means the constellations visible at a certain time of year, or their precise alignment relative to true north, change significantly. The claim by Bauval and Hancock is that the 10,000 BC alignment represents a perfect match for the Orion's belt configuration.
A perfect match.
That's the claim. A unique moment in precessional time that the original unknown builders meticulously intended to immortalize in the very layout of the pyramids.
Unknown builders.
Oh.
Okay, so not the 4th dynasty Egyptians.
Not according to this part of the theory. And Graham Hancock has played a particularly significant and influential role in popularizing and expanding this ancient dating aspect through his internationally best-selling works like Keeper of Genesis, published in 1996.
All right, another huge book.
And The Mars Mystery in 1998, which he co-authored with Bauval, Hancock uses this exceptionally old proposed date for Giza to support his overarching, much grander theory, which posits the existence of a vanished, incredibly advanced progenitor civilization that was wiped out by a cataclysm around 10,000 BC.
Okay, the lost civilization idea. Atlantis-like.
Sort of, yes. He argues that this lost civilization possessed sophisticated technology and knowledge far beyond what we typically attribute to that era, and that its influence shaped and jump-started the development of many of the world's early known civilizations. He points to supposed evidence of this lost civilization at other global sites like Göbekli Tepe in Turkey or Tiwanaku in Bolivia, though we won't deep dive into those today.
Right, stick to Giza for now.
The Giza complex, in this expanded view, becomes a monumental message, a coded warning, or perhaps a legacy from this lost, highly evolved era, designed to be discovered and understood by a future civilization, perhaps even ours.
Wow. That really elevates the stakes, doesn't it? From tombs to messages across millennia. So, the theory doesn't just stop at the pyramids in a distant, almost unimaginably old date. It brings in the Great Sphinx, transforming it into another crucial piece of this ancient cosmic puzzle.
Exactly. It's like a grand master plan, a complete terrestrial map designed by an incredibly sophisticated forgotten culture.
So what exactly is the connection here, and how does the Sphinx fit into this radical timeline?
The Sphinx is indeed a critical, almost symbolic component of this expanded theory. The argument put forward by Bauval and Hancock is that the Great Sphinx was supposedly constructed around 10,500 BC.
Even older than the 10,000 BC date for the pyramid's alignment.
Well, around that same epoch, yes, making it thousands of years older than any established Egyptian dynastic period. Its very form, its iconic leonine shape, is presented as a definitive and deliberate reference to the constellation of Leo the Lion.
Ah, Leo the Lion. Okay.
The theory suggests the builders chose this form for a very specific astronomical reason related to that ancient date.
And what's the astronomical claim for 10,500 BC for the Sphinx?
Just like with the pyramids in Orion, there's a specific astronomical claim. Proponents assert that 10,500 BC is the only time in the vast 26,000-year cycle of the precession of the equinoxes when the astrological age was Leo and when that constellation would have risen directly east of the Sphinx at the vernal equinox.
The spring equinox. Okay, that sounds very specific.
Incredibly specific. The vernal equinox, the first day of spring, has long been a significant marker for ancient cultures tracking celestial phenomena. This incredibly precise alignment, they argue, is far too specific and unique to be mere coincidence.
So, again, suggesting intentional design by ancient, knowledgeable builders.
That's the argument, embedding a precise astronomical timestamp into the very landscape. When you synthesize all these elements, the full terrestrial map proposed by Hancock and Bauval emerges. The Great Sphinx representing the constellation Leo.
Gazing east at its celestial counterpart rising.
The Giza pyramids representing the constellation Orion, specifically Orion's belt, and the Nile River representing the Milky Way galaxy. All of these terrestrial features are claimed to reflect their precise celestial appearance in the sky around 10,500 BC.
Okay, that is a grand vision.
The entire arrangement, as Hancock famously put it, is seen as a frozen astronomical pattern, a monumental timestamp from an incredibly distant past, offering proof of a lost civilization that predates all known advanced cultures.
It's a compelling story, you have to admit.
But, yes, there's a significant but. It's absolutely crucial to provide context here, especially for you, the listener, who wants to be truly well-informed. While these theories present a deeply compelling, imaginative, and truly grand narrative,
Yes.
they stand in stark contrast to conventional archaeological understanding and the vast body of evidence accumulated over centuries of painstaking research and excavation.
Okay, so what does the mainstream say?
The prevailing academic view, based on extensive archaeological findings, including pottery, tools, internal inscriptions, carbon dating of organic materials found within and around the structures, and comprehensive historical texts and records.
A lot of different lines of evidence.
A lot of evidence. It indicates that the Giza pyramids were constructed during the 4th dynasty period of ancient Egypt, which falls squarely within the 3rd millennium BC. For instance, the Great Pyramid of Khufu is widely dated to around 2580 to 2560 BC, with the others constructed in the following decades.
So 2500 BC versus 10,000 BC, that's huge.
It's a chasm, 7,500 years difference. And the exact date of the Great Sphinx, while still debated among mainstream scholars on certain nuances of its carving and renovation, is generally placed within the same 4th dynasty period, typically around 2520 BC to 2494 BC, and it is widely attributed to King Khafre, whose causeway leads directly to the Sphinx.
Khafre, the builder of the second pyramid.
Correct. So we're talking about a difference of roughly 8,000 years between the OCT's proposed date and the accepted archaeological timeline. This is not a small discrepancy that can be easily reconciled. It's a fundamental conflict at the very bedrock of our understanding of ancient Egyptian history.
That's a massive temporal gap, almost unbelievable to consider, and it immediately signals a deep divide between these grand theories and mainstream archaeology. This theory, while undeniably popular with a certain segment of the public,
Very popular.
has indeed faced significant, rigorous criticism from the academic world, particularly from Egyptologists and astronomers. So how do scholars, particularly those in the fields of archaeology and history, categorize these arguments made by Bauval and Hancock?
Well, the arguments put forward by Hancock, Bauval, and others regarding these correlations, and particularly their radical dating for Giza, have been widely described by the academic community as a form of pseudo-archaeology.
Pseudo-archaeology. Okay, what does that mean exactly? Is it just dismissive?
It's not meant as a casual insult, no. It's a classification used by scholars to distinguish between verifiable scientific inquiry and claims that, while appearing to deal with archaeological subjects, fundamentally diverge from established scientific practices.
So it's about the method.
Exactly. Pseudo-archaeology often involves taking archaeological data and artifacts and interpreting them through non-scientific methods, or without adhering to the systematic collection, analysis, and peer-reviewed interpretation of evidence that forms the bedrock of academic archaeology. It suggests a departure from the rigorous methodology of scientific investigation, often starting with a conclusion.
Right. Having the answer first.
And then seeking evidence to support it rather than letting the evidence lead to the conclusion.
And this isn't just a debate among archaeologists. This is where it gets truly revealing because two prominent astronomers independently put the Orion Correlation Theory to the test using their scientific methods and tools.
Yes, bringing the astronomy into it directly.
When the theory is fundamentally about stellar alignments, what did they find when they looked at the stars themselves?
This is a critical point because the theory is, at its heart, an astronomical claim. The astronomers who rigorously tested the OCT were Ed Krupp, the director of the Griffith Observatory in Los Angeles.
Oh, very well-known astronomer.
Very well known. And Tony Farrell, a professor of astronomy at the University of Cape Town in South Africa. They both independently investigated the claims, using sophisticated planetarium equipment to accurately simulate the night sky as it would have appeared in 10,000 BC.
Okay, so they could actually see the sky from that time.
Precisely. Planetarium software can precisely reverse engineer celestial positions based on known astronomical mechanics like stellar proper motion and Earth's precession, allowing astronomers to see the sky exactly as it appeared at any point in history.
And what did they find? Did it match?
Their findings revealed direct and significant astronomical discrepancies that challenge the core premise of the OCT. First, let's talk about the fundamental angle mismatch.
Angle mismatch.
Yes. Krupp and Farrell found that the angle between the alignment of Orion's belt and true north during the 10,000 BC era, as accurately simulated by their planetarium, was approximately 47 to 50 degrees.
Okay, 47 to 50 degrees in 10,000 BC.
Now, compare this to the actual angle formed by the Giza pyramids on the ground, which is measurably 38 degrees.
38 degrees, that's not close.
It's not close at all. It's a fundamental mathematical contradiction of 9 to 12 degrees. The shapes simply do not align at the proposed time.
That seems like a major blow to the perfect match idea.
It's a very significant one. Second, Krupp specifically pointed out what he termed the upside-down problem.
Upside down, what does that mean?
He observed that the slightly bent line formed by the three Giza pyramids on the ground deviates north at one end.
Okay.
Conversely, the slight kink or deformation in the line of Orion's belt, as seen in the sky, is actually deformed south.
Oh, so they bend in opposite directions.
Exactly. So to make these two lines match visually, one of them literally had to be turned upside down or inverted.
Seriously, they had to flip one of them.
And this is precisely what Krupp noted had been done in Bauval and Gilbert's original, highly influential book, The Orion Mystery. The image of the pyramid's map was inverted to achieve a visual correspondence.
Without telling the reader.
But this inversion was not clearly disclosed to the reader, according to Krupp. This act of inversion, necessary to achieve a visual proof, highlights a significant manipulation of the data to fit the hypothesis, which is a major red flag in scientific methodology.
Wow. That's a huge revelation, isn't it? The idea that one of the core visual proofs presented to the public was literally flipped to make it appear to work. It makes you wonder what else might have been adjusted. But were there any other major issues that these astronomers or other experts found beyond those direct angle and inversion problems? The theory paints such a broad picture. Surely there are other points of contention.
Absolutely. Beyond those direct astronomical contradictions with the pyramids, Krupp and Farrell, along with other Egyptologists and historians, highlighted several other fundamental issues that seriously undermine the broader Orion correlation theory, particularly its extended claims about the Sphinx and the Nile.
Okay, like what?
For instance, consider the proposed grand terrestrial map, the Sphinx as Leo, the pyramids as Orion, and the Nile as the Milky Way.
Right, the big picture.
If this grand cosmic map were accurate, then in the celestial arrangement, the constellation Leo is on the opposite side of the Milky Way from the constellation Orion.
Okay, Leo and Orion are on different sides of the celestial river.
Correct. However, on the ground, the Sphinx is situated on the same side of the Nile River as the pyramids.
Oh, So the map doesn't actually match the geography there.
The physical arrangement on the ground simply does not match the proposed celestial arrangement in this regard. It breaks the geographical consistency of the map.
Huh. Okay, that's another significant point.
Another critical astronomical and historical point they raised concerned the vernal equinox. The theory's dating of the Sphinx to 10,500 BC relies heavily on the claim that this was the only time the vernal equinox occurred in the astrological age of Leo.
Right, the key dating mechanism for the Sphinx.
However, their precise calculations showed that the vernal equinox circa 10,500 BC was actually in the constellation of Virgo, not Leo.
Virgo, not Leo.
Virgo. This directly contradicts a core foundational tenet of the theory's dating mechanism for the Sphinx. If the starting premise of your calculation is wrong, the conclusion is inherently flawed.
So the whole Leo connection at that specific time falls apart astronomically?
According to these calculations, yes. And perhaps even more fundamentally for Egyptology and historical context is the very origin of the zodiac itself.
What about it?
The constellations of the zodiac, including Leo, originated in Mesopotamia, not Egypt.
Mesopotamia, like Sumeria, Babylon.
Exactly. They were entirely unknown in Egypt until the much later Greco-Roman era, which began around 332 BC, literally thousands of years after the supposed 10,500 BC construction date.
Wow. So the Egyptians in 10,500 BC wouldn't have even known about Leo as a constellation.
Correct. This means that the ancient Egyptians of that hypothesized period would not have even possessed the concept of the Age of Leo as understood and utilized by the theory. It would be akin to claiming Shakespeare wrote computer code in Python. The concept and technology simply didn't exist in his time.
That's a profound anachronism, isn't it?
It introduces a profound anachronism, a cultural and historical disconnect that is extremely difficult for the theory to reconcile with established historical understanding.
So not only do the angles not align and the maps need to be literally flipped, but the very astronomical and cultural concepts used to define the theory's timeline and meaning didn't even exist in Egypt at the proposed time. That's a significant, almost overwhelming pile of counterarguments. But the age of the Sphinx is such a central component of the OCT, and it's often linked to geological evidence. What about the geological arguments that have been put forward?
Yes, the erosion argument.
The idea that the Sphinx shows signs of being much, much older than conventionally accepted, indicating extensive water erosion.
You're right to bring that up, because the geological argument for an older Sphinx is often cited by proponents of the OCT as crucial supporting evidence. There has been limited geological support for an older Sphinx from a few individuals.
Like Robert Bauval.
Exactly. Robert Bauval, a geologist, famously argued in the early 1990s that the specific patterns of deeply incised, undulating erosion visible on the Sphinx and its surrounding enclosure suggest that parts of the monument must have been carved much earlier, positing a date between 7,000 and 5,000 BC at the latest.
Based on rainfall patterns.
He argued this indicated a period of significant rainfall and runoff that couldn't have occurred during the arid 3rd millennium BC, when mainstream Egyptology dates the Sphinx. Another geologist, Colin Reeder, suggested a date only several hundred years prior to the commonly accepted 4th dynasty date, so not as radical as Shirk's, but still pushing it back.
Okay, so there are some geological voices supporting an older date.
Some, yes. However, it is crucial to emphasize that these views, particularly Shirk's more radical dating, have been almost universally rejected by mainstream Egyptologists and the vast majority of geologists who have studied the Sphinx in depth.
Almost universally rejected. That's strong.
It is. This includes prominent geologists such as James Harrell, Lal Gowrie, John J. Sinai, and Jayanta K. Bandyopadhyay, who have conducted extensive on-site analyses.
And what do they say causes the erosion, if not ancient rain?
Their analyses provide robust mainstream geological explanations for the Sphinx's wear and tear that do not require an extreme ancient age or a period of heavy rainfall. These explanations attribute the apparently accelerated wear to several factors. Firstly, modern industrial pollution.
Right. Acid rain and such.
Has caused significant chemical decay of the limestone. Secondly, there are known qualitative differences in the various layers of limestone within the monument itself, meaning some layers are naturally softer and erode faster than others, creating the undulating patterns without requiring water.
So the rock itself isn't uniform.
Precisely. Thirdly, and very significantly, in a desert environment, scouring by wind-borne sand over millennia is a powerful abrasive force. Wind erosion typically leaves very specific patterns, like fluting and undercutting, distinct from the broader, smoother, and more uniform patterns of water erosion.
Geologists can tell the difference.
They can differentiate these very clearly. Lastly, natural temperature changes, with significant daily and seasonal fluctuations in the desert, cause the stone to expand and contract, leading to cracking and deterioration over time, a process known as salt weathering.
So standard geology can explain it.
These are well-understood geological processes that are sufficient to explain the observed wear within the accepted time frame of its construction in the 3rd millennium BC, eliminating the need for a radically older date or a wetter climate.
This clash between compelling, grand theories and rigorous academic scrutiny often spills over into the public sphere, especially when a theory captures the public imagination as powerfully as the Orion Correlation Theory did.
Absolutely, it became a huge public phenomenon.
The immense popularity of these ideas eventually led to a high-profile public examination.
Yeah.
So what happened when the BBC, a major globally respected media outlet, decided to get involved and critically examine these hypotheses?
It was indeed a significant moment in the public discourse surrounding these theories, bringing them from academic and niche popular circles into the mainstream spotlight in a different way. On November 4, 1999, the BBC broadcast a documentary titled Atlantis Reborn.
Atlantis Reborn, yeah.
The stated purpose of this program was explicitly to critically test the ideas that had been put forward by Robert Bauval and Graham Hancock concerning ancient advanced civilizations and their supposed influence on sites like Giza, as well as other claimed ancient mysteries around the world.
So it wasn't just promotional, it was meant to be critical.
It was meant to be an in-depth examination featuring expert opinions, not an endorsement of the theories.
Unsurprisingly, a critical documentary like that can lead to some very strong reactions, especially when it challenges deeply held or widely popularized beliefs about ancient history.
Mm-hmm.
What was Bauval and Hancock's response to the BBC's program, given its critical stance? Did they push back immediately?
Their response was immediate and formal, as you might expect. Bauval and Hancock, feeling that their work had been misrepresented and unfairly criticized, filed a complaint with the Broadcasting Standards Commission, or BSC.
Okay, the official regulator.
Yes, the BSC was the independent regulatory body for broadcasting standards in the UK at the time, tasked with ensuring fairness and accuracy in television and radio programming. They alleged that they had been treated unfairly and that the documentary had presented a skewed or incomplete picture of their theories.
So they took it to the authorities. What happened?
A formal hearing followed, and in November 2000, the BSC issued its ruling. The outcome was highly significant and largely supported the BBC's editorial stance. The BSC largely ruled in favor of the documentary makers on 9 out of their 10 principal complaints.
9 out of 10. In favor of the BBC.
Correct. This means that for the vast majority of the specific points where Bauval and Hancock claimed unfair treatment regarding the documentary's criticism of their theories, the BSC found that the BBC had acted fairly and had presented the counter-arguments appropriately.
So what was the one complaint that was upheld?
Only one complaint out of the 10 was upheld. This singular, minor complaint concerned the omission of Bauval and Hancock's rebuttal to one specific argument against the Orion Correlation Theory.
Just one specific point about the OCT.
Yes. It was a procedural issue related to editing balance, not a refutation of the scientific criticisms themselves. This implies that while there was a minor oversight in the editing process for that single point, the core criticism and scientific refutation of their theories were deemed fair and properly presented by the BBC.
So the overall critique stood.
Yes, and specifically, the BSC explicitly concluded that Bauval and Hancock had not been treated unfairly regarding the criticisms of their theories concerning carbon dating of artifacts, the Great Sphinx of Egypt's age, Cambodia's Angkor temples, Japan's Yonaguni Formation, and the mythical lost land of Atlantis, all of which had been featured in the documentary.
Okay, so a fairly comprehensive ruling against their complaints.
It was a clear message that the documentary's overall critical stance was journalistically justified and well supported by expert opinion.
So what does this all mean for the BBC and for the future of the documentary? Did they completely back down or retract their stance after that one upheld complaint, or did the conversation continue to evolve?
It's a nuanced outcome, and it's important to understand the full picture. The BBC, in accordance with the BSC ruling, did offer to broadcast a revised version of the documentary.
Okay, they agreed to revise it.
Which Bauval and Hancock welcomed as a step towards addressing their concerns. This revised version, titled Atlantis Reborn Again, aired on December 14, 2000, about a month after the BSC ruling.
Atlantis Reborn Again, got it.
However, and this is crucial for understanding the lasting impact, even the revised documentary continued to present serious doubts about Bauval and Hancock's ideas.
So it wasn't a reversal.
Not at all. It was not a retraction of the scientific criticisms or an endorsement of their claims. Far from it. The documentary still prominently featured and showcased critical perspectives from a range of respected and credentialed experts in their fields.
Like Krupp and Farrell again.
Yes, these included astronomer Anthony Farrell, whom we discussed earlier regarding the angle discrepancies, Ed Krupp of the Griffith Observatory, who highlighted the upside-down problem and other astronomical issues, Egyptologist Kate Spence of Cambridge University, who provided the mainstream archaeological and historical context for the dating of Giza, and Eleanor Mintaka of the University of Michigan, another expert in Egyptian architecture and astronomy.
So the scientific counter-arguments remain prominent.
Absolutely. Their expert opinions, which were largely critical of the Orion Correlation Theory and related ideas, remain central to the narrative, reinforcing that the core scientific and archaeological objections were still very much valid and presented clearly to the public. It demonstrated that even with a minor procedural adjustment, the substance of the critical analysis remained firmly intact, and the scientific consensus was reiterated.
This deep dive into the Orion Correlation Theory has offered us a fascinating look at a very specific, compelling idea about ancient wonders. But beyond the specifics, it illuminates a much broader and frankly crucial point for all of us as learners. How we evaluate information, how we engage with new ideas, and how we distinguish between incredibly compelling narratives and verifiable evidence-based facts. It's a skill set that goes far beyond ancient Egypt.
That's precisely it. This entire discussion reflects on the very nature of what we call fringe theories or alternative histories. They often tap into something deeply human within us, our desire for grand narratives, for hidden knowledge, for a sense of profound mystery and purpose in the ancient past.
It's that allure of the secret history.
Exactly. The idea of a lost, advanced civilization or secret knowledge appeals to our sense of wonder and perhaps even our dissatisfaction with seemingly mundane mainstream explanations. It's a powerful allure, and it explains why such theories gain widespread traction despite a lack of mainstream scientific acceptance.
But science demands more.
But science, the scientific process, whether in archaeology, astronomy, or geology, demands something different. It requires rigorous proof, reproducibility of findings, and consistency with existing, verifiable data. The Orion Correlation Theory, despite its widespread popular appeal and the compelling narrative it weaves, highlights the absolute importance of critical scrutiny. It shows us why extraordinary claims require extraordinary evidence, and how that evidence is then put to the test by the broader scientific community, regardless of how captivating the story might be.
So it's a case study in critical thinking, really.
Absolutely. So, as you reflect on this deep dive, here are some core insights and principles we hope you, the listener, can take away and add to your knowledge toolkit, not just for understanding the Orion Correlation Theory, but for navigating the vast landscape of information we all encounter daily. This deep dive offers a masterclass in critical thinking when faced with extraordinary claims, whether they are about ancient civilizations or modern-day phenomena.
Okay, what should people keep in mind?
Remember these foundational principles. First, the burden of proof always rests on the claimant. If someone makes an extraordinary claim, they are responsible for providing extraordinary, verifiable evidence to support it.
Don't just accept it because it sounds cool.
Right. Second, look for internal consistency. Do all parts of the theory align logically, or do fundamental contradictions emerge, like the upside-down problem in the OCT or the anachronism of the zodiac?
Does it make sense within its own logic?
Third, scrutinize the scientific methods used. Are they reproducible? Do they align with established bodies of evidence from multiple disciplines, or do they dismiss well-supported consensus views without offering robust counter-evidence?
Check the methodology.
Fourth, consider the source and potential biases. Are the proponents operating within established academic frameworks, or are they consistently outside of them, perhaps appealing directly to public sentiment rather than peer review?
Where is the information coming from?
And finally, always seek multiple, diverse perspectives, especially from experts in the relevant fields. Applying these filters empowers you to navigate the vast landscape of information, distinguishing compelling narratives from verifiable facts, and strengthening your own capacity for informed judgment.
That's a perfect distillation. It really does remind us how valuable it is to understand why certain ideas are accepted or rejected within academic and scientific communities. It's about so much more than just labeling something as right or wrong. It's about the quality, the rigor, and the interpretation of the evidence, and the process by which knowledge is built and challenged.
Precisely. The process matters enormously. #tag outro. This deep dive into the Orion Correlation Theory leaves us with a truly provocative thought. What does our enduring human fascination with grand, hidden explanations for ancient mysteries tell us about our own desire for meaning, for wonder, and perhaps for a deeper connection to the cosmos,
Hmm.
even when those explanations might conflict with the available evidence? It's a powerful and persistent pull within the human spirit.
It really is. And consider this for yourself. The allure of a secret, advanced past, a lost golden age, is incredibly powerful. How do you discern between what might be a truly new, groundbreaking discovery that genuinely challenges the status quo with compelling evidence, and a compelling narrative that, while fascinating, might ultimately lack factual grounding?
A crucial question.
It's a critical skill, more vital than ever in our complex age of information. Thank you for joining us on this deep dive. Until next time, keep exploring and keep asking those big questions.